Welcome everyone to Knox Game Design for August 2023. My name is Levi Smith. So this month I'm going to start out with a little bit of an announcement. So we're not going to have a game jam kickoff next month in September, but I recommend going out and checking out, if you're in Knoxville, checking out this Dev Moot conference, technical conference hosted by Cody Lambert. So he heads up the Knox Devs group. So if you're in tech and want to check out a conference, it looks like this is shaping up to be a good one. Looks like they already have speakers and lined up. It looks like it's one day. But yeah, I think I think the early bird tickets were closed, but it looked like you can get tickets for $50 right now. So yeah, check that out if you're in Knoxville, interested in a technical conference. I know there hasn't been many lately, so it's good to see conferences out there, more of them starting back up. So this month, I'm going to talk about character encoding. Really didn't have any thoughts on anything to talk about this month, and I was just playing around, found some cool things out, things I never knew about. So basically, characters or letters, A, B, C, D, all the way up to Z. So how those are stored in a computer. Those are stored as integer, whole number values. Different types of encodings out there. The one that I started out with is ASCII, the American Standard Code for Information Interchange. Then along came Unicode, which added many more characters and from different languages. And also, you can also encode letters just as their position in the alphabet. A is 1, B is 2, C is 3, all the way up to Z is 26. Or some people specify A0, Z25, or A1, Z26, depending on whether you start out as A as 1. But ASCII is just for Unicode, for Latin characters and numerals. And oh, by the way, the ASCII encoding for all the 26 Latin letters, the letters that we use in English, correspond, their values correspond with the same values in Unicode. So this is how I learned a long time ago. I just memorized capital A was 65 and lowercase a is 97. Never understood why. I just kind of looked in one of my computing books. And so the nice thing about this, if you need to increment your character, you can just add 1. So 66 is B and 67 is C and so on. So yeah, so to get the character value, I always thought of it as you could take whatever letter you're thinking about, and then, like for example here, a K is the 11th letter in the alphabet, so you just take that character position in the alphabet, do 65 minus 1, then add that. So 65 minus 1 is 64. Then add 11, that gives you 75. So its ASCII or Unicode value is 75 for N. So the lowercase letters, as I said, start at 97. So it's the same thing. And then it's the 14th character of the letter of the alphabet. So you do 97 minus 1 plus that position, 14, you get 110. So I guess as I went along, I kind of noticed that 65, that's really close to 64, which is a factor of 2, or 2 to an exponent. And then the same for 97, 64, plus a factor of 2, a power of 2, is 96. And oh, by the way, if you're new to programming, if you're using a low-level language like C, be aware that all strings are terminated with a character value of 0. So a string is a series of characters, which gives you like a word or a series of words. So encoding Knox in capital letters, or actually that should be a lowercase n right there. I believe. Yeah, that should be capital K, lowercase n, lowercase o, lowercase x. I'll fix that. But be aware that that's like 75, 110, 111, 120, and then a 0 for the null value to terminate that. Otherwise, whenever it prints out a string, it's just going to keep going, and if there's trash in memory, it's just going to print out all those trash characters. I think I did some testing. These days, they generally just blank out those, but just be aware of that. Okay, so here's some C code. I've installed the MSys, or now it's like UCRT64. MSys2 is a nice, like, Unix simulated environment you can get for Windows. Used to be like Cygwin and MSys2 and all that. I think it's still MSys2, but they install like 5 different versions. I can't tell you why. They're a little bit different. But make sure, like, I just had a problem. Like, I went in and had some stuff set up, and then I came back and it wasn't working. It's because I started MSys2 when I installed all the stuff on UCRT64. So make sure you start the platform or version that you started with. So yeah, I got a little program here that I wrote. So character encoding. Oops, it's VIM. That. So this just goes to show that a character string, you can just create an array of 5 characters, and then you can assign those values right into your string: 75, 110, 111, 120, and 0. Then I hadn't installed GCC, but do character encoding 01.c for /a. It creates a.exe by default. So there's Knox right there. So we printed out that array of characters without ever typing a letter in there. We just did it by putting the ASCII values into the array itself. So I don't know, maybe everybody knows that. I don't know, but it's pretty neat little trick there. Okay, so this is what I learned like after almost three like decades of programming, and it just kind of hit me. So capital letters start at 64 plus 1. Lowercase letters start at 96 plus 1. Numerals start at 48. So the numbers are kind of the same. Numerals are kind of the same as letters. So 48 is a 0. 49 is a 1. 50 is a 2. So I think I mentioned a little bit later on, but the number 1, an integer 1, is significantly different than the character 1. So if you're new to software development programming, that's something to be aware of. A lot of scripted languages these days, they handle the conversion behind the scenes, but if you're using an older language, you may have to do a cast where you just put the data type next to it. That way you know what you're working with. Yeah, so here it is. I was afraid to say it earlier, but yeah, 64 is 2 to the 6th. So yeah, if you notice that the capital letters start at 64, and that actually equals 2 to the 6th, and the lowercase letters start at 96, which is 2 to the 6th plus 2 to the 5th. So if we show that in binary, if you start out, the least significant bit is on the far right. So you start out, that's 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, which is 64. And then, so that's 2 to the 0 is 1, 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16, 2 to the fifth is 32, and then 2 to the sixth is 64. So 96 is just 2 to the sixth plus 2 to the fifth. So that's 0, 1, 1, 0, 0, 0, 0, 0. So the only difference between the capital letter and lowercase letter is that that fifth bit from the right. Actually, 2 to the fifth, which is the 6th bit. So you got to realize when you're talking about 2 to the power, you start out at 2 to the 0. So the 6th bit is 2 to the 5th, and the 7th bit is 2 to the 6th. that can get confusing. And then what kind of blew me away is the alphabet position. The position in the alphabet is determined by the first 5 bits. So if you kind of think about it, like I said earlier, capital A, so that's capital A and lowercase a, they're both the first character in the alphabet. So if you do 64 plus 1, that's 65. Then 96 plus 1 is 97. So capital A, lowercase a. So if you look at the first 5 bits for both of those, then it's 0, 0, 0, 0, 1, which is 1. So if you look at an L, it's the 12th character in the alphabet. So if you do 64 plus 12, that's 76. So 76 is a capital L. If you do lowercase l, still the 12th character in the alphabet. That's 96 plus 12 equals 108. So capital L is 76, lowercase l is 108. But if you look at the first 5 bits, the 5 bits on the far right, I don't know if you can see my cursor or not, but they're the same. 0, 1, 1, 0, 0, which is 12. So that's so cool to realize that if you just look at those first 5 bits, that tells you in the alphabet the location of that character. Oh, by the way, if you look at the 0 character, that's actually the @ sign for uppercase. I think it's like a tick mark, the backward apostrophe for the lowercase characters for 0 position. So why is this important? Like I just said, you can get the alphabet position of a character if you know its ASCII value. If you got its ASCII value, you can just set the first 3 bits, the most significant bits, to 0, and the remaining 5 bits will give you the alphabet position. So you can use a mask 0, 0, 0, 1, 1, 1, 1, 1 with your character. So here we got a bit B, and to do a bitwise. So this is a little bit of talk on bitwise, bit operators as well, which I really haven't ever used before. So this is giving me a little bit of experience with bit operators. But you can take a byte and then apply that mask, which is 31, and just do an ampersand, and then that will give you the position in the alphabet of that character. Other thing you can do, you can change the capitalization of a letter. So if you just flip that 6th bit, the one that signifies whether it's capital or lowercase, which is 2 to the 5th, so that's 32. So you can actually flip a bit using XOR. So that'll flip whatever bits have a 1. So if you want to flip the 5th or the 6th bit, you just do 0, 0, 1, 0, 0, 0, 0, 0, and you do a exclusive OR, which you do your byte, which is your character, then you do a caret, then I have 32, which is the mask right there, 0, 0, 1, 0, 0, 0, 0, 0. So that will flip the 6th bit right there. So that's kind of like the tilde in the VI editor. It'll flip it from capital to lowercase. If you want to make a character lowercase, you can use the bitwise OR with a mask of 32. So again, that mask of 32 is just all zeros with a 1 in the 6th bit. That 6th bit is the capital, signifies whether it's capital or lowercase. So you take your byte, and the bitwise for OR is a pipe. So you do B pipe 32, and then that will make whatever character that is lowercase, whether it's already uppercase or lowercase. To make a lowercase letter uppercase is a little bit more complex. You have to use an and then a mask. So you take 32, then you which is all zeros except for 1 in the 6th position. Then you do XOR with 255. So 255 is all 1s. So basically, to make something a 1, always a 1, a bit always 1, you have to, the 0 signifies the thing that you want to make a 1. So it's got to be all 1s, and then whatever you want to make a 1, you have to have a 0 in that position. So that's what we're doing with this 32 XOR 255. So whatever bits you want to flip to 1, that's going to be in this 32 value right here. And then you just XOR 255. And then you take that, and then you take your original byte, and then you AND with that value. So yeah, making a value, setting a bit to 1 is a lot easier than setting a bit to 0. A little bit more complex. So yeah, here's a look. So just to show you can do this in Unity, I wrote a little simple Unity program. So it takes whatever's in your inspector right here. You can type a message in there. And then what it's going to do, you got 3 little demos. So the first one, it's going to flip, kind of like I was talking about with the XOR. It's going to flip the capitalization of that character. Second demo, it's going to make everything lowercase, whether it's already uppercase or not. And then the third demo, we're going to make everything uppercase. So it's basically the same thing that I just went over, just in code. So yeah, let's take a look at this. Already got up and running here. So our message is going to be, I got it here in the canvas in text, Knox game design. Maximum, that's when I play. So it's Knox game design with a capital K, capital G, and a capital D. Let's go ahead and run this. And maximize. Yeah, it might still be kind of hard to see. But what it's basically doing for every index, it's looking at the character at that index. I can scale it up a little bit right there. Yeah, there we go. So it's looking at the character at that index. Then it's getting the alphabet position of that character by looking at the 5 least significant bits. And then it's also getting the case of that bit. So if the case bit is 0, then it's capitalized. If it's 1, it's lowercase. So, and here it's just printing out the binary of that original character. So in this first demo, we're going to flip the 6-bit. So like a capital D becomes lowercase d, lowercase x becomes an uppercase bit, x, just by flipping that 6th bit. So I think it's pretty cool. I don't know if you could really use this for a game or not, but let's look at the next demo. This one may not be too helpful either. So we just changed the demo to 1. And maximize. So this is taking Knox game design and it's making everything lowercase. So it's basically making the capital K lowercase, capital G lowercase, and capital D lowercase, just by setting the 6th bit to 1. So the second demo, demo number 2, which is actually the third demo, maximize that. So now we're capitalizing everything. So we're making Knox game. So this might actually be kind of helpful right here. I can think of a couple of cases. I think I put it on the slide later. So, well, for one, if you're taking user input, let's say you don't have a string library for whatever reason. You don't have a string library, or maybe you're working on an emulator, an old console emulator. It doesn't have a string library, and you want to take the user's input, you want to make it capitalized because you don't want to like have to, whenever you're comparing like user input with a set like commands, you don't want to have to figure out case. So you just want to like compare uppercase and uppercase. So this is one way that could be helpful. Is like I just want the string, whatever the user entered, all in uppercase. Or maybe you have some text and you want to make it uppercase to display to the user, whatever. So this could be helpful if you don't have a string library. But yeah, that's what that's doing right there. And oh, by the way, let's go back to demo 0 where it's flipping the bits. You can go to text or text legacy right here. I can like type in hello in capital, and then world and lowercase, and then let's say I don't know if it handled spaces yet. This is a test. So you can basically type anything in there. And here it goes. It's making hello lowercase, world capitalized, and this is a test. It's going to flip all the characters. So yeah, this works with any message you type in there. And then it's just going to reverse what it just did. Okay, let's go back. So here, yeah, the so what. I think I already talked about some of these. If you don't have a string library, you need to make some things capitalized. This is how you do it. I think I already talked about these. Forcing user input to all capitals could be helpful. And also just knowing how the letters are stored as numbers, bit values, bytes. It's helpful if you need to add or subtract to a letter for, say, grades or rank. You want to increase a grade, like from A to B, but you gotta be aware. Usually in games, A is the best, and like D or F is the worst. So to increase your grade, you're actually subtracting 1 from the character value. Yeah, as I said earlier, it's just good to know the difference between the data types. Character 1 and an integer 1 are two completely different things. And yeah, just be aware that basically everything can be reduced down to a series of ones and zeros in a computer program. Because whenever you compile your program, that's one thing I wanted to do. I wanted to actually look at the code and see if I could dig in with like a hex editor and see those characters. But I didn't get around to doing that. But yeah, one thing, maybe for a future talk, I kind of want to look at opcodes just to show, like, even if you look at assembly, all those assembly commands can be reduced down to number or byte values. They're all just numbers, stored as numbers, all the different opcodes, which I think is kind of cool. Yeah, so that's going to wrap it up for Knox Game Design, August 2023. Hope everyone found it interesting, and I appreciate everyone out there listening and watching.